Now we're in lesson 5. We're going to take the same thing, it's the exact same problems as lesson 4 really, and we're just going to kind of grip and rip them. They're not as complicated here as maybe they were in the other one, or maybe they are, I don't know. We're starting out with number 1, nice and simple. I have x minus y to the 4th power. So I am going to find the 4th row of Pascal's triangle, and I'm going to find the coefficient. So 1, 4, 6, 4, 1. I'm going to build my rows. All right, so my first term is x, it's just x, right? So x is going to get all 4, and as I go, that's an x, I'm gonna lose them all the way across. I'm gonna pick up with my next term, y, it's gonna get all the 4. Before I run out. Okay, so first term, and then back with the second term. This one was nice because it didn't have any real numbers in it. It just had variables, x's and y's. So I don't need to do that, figure out what the real number is business. I can just figure out my term here. 1 times x to the 4 is x to the 4. 4 with 3 x's and a y. 6 with 2 and 2. 4 with x and 3 y's, and then 1 y to the 4. If we don't want to write the 1, you don't have to. Okay, so this was pretty straightforward compared to the ones we did in the previous video. Now I just need to figure out the glue that puts them together. It's a minus. Again, if it was plus, they're all pluses, but it's a minus. So I have to start in between with a minus, and then I can alternate. Boom. Okay. 2 is a similar kind of 1. It doesn't, each term only has one thing, even though this is a real thing. But I'm still gonna find 1, 5, 10, 10, 5, 1. I'm gonna find the row of Pascal's triangle that I need, and I'm gonna be the 5th row. Okay. My first term here is simply r. And my second term is a 3. Okay. So as I begin, my first term, r, gets all 5 of the exponent. And I'm going to pick up where I left off. The second term, 3 to the 5. All right. Now I need to figure out what the real numbers are. Okay, 3 to the 1st is a real number. It's 3. Okay, figure out what those real numbers are. Okay, to get our final answer, multiply down your column. 1 times r to the 5 is just r to the 5. 5 times 3, 15, with 4 r's. And that's it. 10 times 9 is 90, with 3 r's. 27 times 10 is 270, with 2 r's. 5 times that is 405, with n r. And then the very last column, I don't have any r's, I just simply have 1 times this, which is 243. The glue that holds these together was a plus up here, so I don't have to think. I'm gonna add all this stuff together. Okay. In the last video, we talked about how we can check our answer. The exponents, right, should add to 5. This one did up here. This one was 4 because the row was 4. This had 4, 3 and 1, 2 and 2. Okay, that made 4. How come this one doesn't make 5? This one starts with 5 and then I only have 4 exponents and then I wrote that backwards. Okay, all right, well, I'm sure someone noticed that before I did. R to the 3, 2 and then 1 and then none. Where's the other exponent, right? It's buried in the number, okay? Because the second term is just a number. The exponent gets implied in here. So the other 1 exponent that I'm missing, the other 2 exponent, it was buried in, it was factored for, and it turned into this. That's why the number gets bigger, right? So it's hard to check when you don't have that. We don't need to do that one. We don't need to do that one. Sure, how about this one? Number 5, the 6th row of Pascal's triangle. I don't know what it is off the top of my head. Oh man, it doesn't tell me. 1, 6, 15, 20. All right. Okay. 1, 6, 15, 20, 15, 6, 1. Okay, my first term is 2D. My second term is just 3. All right, so as I begin, 2 to the 6, D to the 6, and then I can keep going, right? 2 to the 5, 2 to the 4, but I'm gonna get a little cheeky because I can figure out what 2 to the 5 is right now. I know it's gonna be there. 2 to the 6 is here, I need 2 to the 5, but then remember at the end, I always figure out what the real number is anyway. Why don't I just figure that out right now since I understand what's happening? 2 to the 5 is 32, right? Double check it. 2 times 2 times 2 times 2 times 2. That's gonna give me 4. Times another 2 is 8. Times another 2 is 16. Times another 2 is 32. So yeah, that's gonna be 32. And it's gonna have d to the 5. Alright, now this one's gonna be 2 to the 4th in this column. So that's gonna be 16 with d to the 4th. I'm just figuring out the real number right away. Then I'm gonna have 8, d3, 4, d2, 2, d1, and I run out. If you don't wanna skip that, if you don't wanna like do this and combine right now, don't, okay? Write 2 to the 4th, write 2 to the 3rd, and then go back and get it. Okay. All right, this is 64. 64, D6. Okay, the second term now is 3. This is gonna be 3 to the 6, and I don't know what that is off the top of my head. 3 to the 6 goes here, 3 to the 5, 3 to the 4, 3 to the 3, 3 to the 2, 3 to the 1. Okay, so 3 to the 1 will be here, and it's just gonna be 3. I don't know what that is off the top of my head, but I know this one's 3 to the 1, this one's gonna be 3 squared, this one's gonna be 3 cubed, 3 to the 4th, 3 to the 5th, and then 3 to the 6th. Yeah, I didn't know that. Trusting that that's correct though. All right. So I saved myself some time and some room and maybe some confusion. Or maybe what I've done is confused you further, in which case just go back, do this like we've been doing, okay? All right, final term time. Real times real. 1 times 64 gives me 64. And there's going to be 6 D's here. I'm gonna have 3 times 6 times 32. All those numbers go together. So I'm gonna do 6 times 32 times 3. And my number here is 576. With 5 D's. Here we're gonna have 15 times 16 times 9. And we're gonna get 2,160 with D4. 20 times 8 times 27. 4,320 with 3 D's. 15 times 4 times 81. 4860 with D2. 6 times 2 times 405. Hey, it's the same number. 4860 with 1 D. And then 1 times 1,215, I can do that one. That's gonna be 1215 with no D. Okay. Is this fun yet? So I look back to the glue and I'm like, okay, this thing is glued together by a plus, so that means all these things are pluses. And yes, we do get very, very long answers sometimes. And the numbers get very, very big. But remember, Pascal's triangle is a shortcut to binomial expansion. If you had to do this by hand, you would not be happy. All right, let's take a look at the last type of problem that we look at with these. Right here. Find the indicated term. So I don't need to do the whole thing. I just want the term. So looking at number 6 here, I want the 4th term. I'm still dealing with the 5th row, so I need to do that thing. 1, 5, 10, 10, 5, 1. I still am gonna set up my problem. But because it only cares about the 4th row, or sorry, the 4th term. 1, 2, 3, 4. This is the column that I care about. I don't need to do the rest. My first term is still what it was. In this case, it's 5x. Okay. So as I fill this out, I would know that this would be 5 to the 5, x to the 5. That's how I always start. The first term gets all of the exponent. 5, 5, x 5. 5, 4, x 4. 5, 3, x 3. 5, 2, x 2 would be here. And that makes sense because we would have 5, 1, x 1, and then we would run out. Okay. Now this is really 25 x squared. So I'm gonna look at that. Now, my second term would be begin here, and it would go 2 to the 5th, y to the 5th, 2 to the 4th, y to the 4th, 2 to the 3rd, y to the 3rd. Okay. And then 2 squared, 2 to the 1, nothing. This really is 8y cubed. Okay, because I have to figure out those real numbers. Now I'm gonna kind of eliminate this, because I'm only gonna look at this as I get my final answer. Real number times real. 10 times 25 times 8. That's 80 times 25. That is what, 2,000? I don't know. 2,000. And it has 2 x's and y cubed. So that's the number that goes there. That's the answer for the number. But I gotta figure out the sign. The glue that held this together was plus. So everything was plus. Okay, no thinking. Boom, answer done. But down here in number 7, I might need to do some thinking. And that gets big, so we're not doing that one for sure. The third term of this. So it's x to the 8. I need my numbers for Pascal's triangle in the 8th row. Oh boy. Oh no. Oh boy. Row 8. Oh goodness gracious. Okay. You guys have the benefit of hindsight. You can look at this. I can't do that. I could have it printed in front of me. That would be smart. But I don't. I almost did the 12. Look at that. Okay, the third term of this. My rows in the third row are 1, 8, 28, 56, 70, 56, 28, 8, 1. And this time I care about the third term. So first, second, third. All right. First term was x. Second term was 2. So this would be x to the 8, right? I got 8 x's. I almost got confused because I'm looking for the third term. X to the 8, x to the 7, x to the 6. I don't care about the rest of it. This is gonna be 2 to the 8, 2 to the 7, 6, 5, 4, 3, 2, 2 to the 2. Okay, well that's 4. I was expecting this to be scary. It's a little disappointing. All right. Close it up. 28 times 4, I think, is 144, but I don't want to be wrong. 112, see, I would have been wrong. And then that's where it is. 28 times 4 has x to the 6 hanging out with it. But the glue that holds this one together is a minus. So that might change what I have to write. I would, in between here, between my first and my second term, that would be the minus between the first and the second term. This one would end up being a plus. After this would be a minus. Turns out this one is positive as well, but it might not have been. It might not have been. Okay. If you wanted to look at your pattern differently in terms of like plus minus, the first one is always plus, the second term will be minus, the third term will be plus, minus, plus, minus, plus, minus, plus, and so on and so on. So if you wanted to label your columns with the sign associated with it, that would be fine too. That's another way to do it. Okay. All right, good luck. You can do this.